Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA.
Today we are going to solve this interesting problem of IIT JAM MS 2020, problem 38. It is an MSQ type question. So we need to check whether these following four options are true or not. So we need to check all the four integrals one by one.
Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT JAM MS, ISIM Stat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So let us see the solution. So we have the integral 0 to 1, double integral 0 to 1 e to the power maximum of x square y square dx dy, x running from 0 to 1, y running from 0 to 1. Now we are breaking this inner integral from 0 to y and y to 1 because y lies in the range 0 to 1. So we can break this integral in this form. Now this integral becomes 0 to 1, the inner integral becomes 0 to y, this thing becomes e to the power y square, and this part becomes e to the power x square. The reason is here x lies in the range 0 and y, so x square is less than y square, so the maximum of x square and y square will be y square, as y square is greater than x square, so this thing is becoming e to the power y square into dx. Similarly, in this case, when y is in the range when x is in the range y to 1, then x square is greater than y square. In that case, maximum will be x square, so this thing is becoming e to the power x square dx. So then it is a simple integral calculation. We are getting these two integrals, 0 to 1 y e to the power y square dy, and the double integral e to the power x square dx dy, x running from y to 1 and y running from 0 to 1. We are denoting these two integrals as I1 and I2. Now let us first evaluate I1, which is 0 to 1 y to the power y square dy. It is a simple integral. We can calculate it by substituting y square equal to t, and we are getting I1 as half into e minus 1. Now the main part comes. We have to evaluate this double integral 0 to 1 y to 1 e to the power x square dx dy, which is our I2. We note that to solve this integral, we will have to change the order of integration. I am assuming that you all know how to change the order of integration. So I2 is our 0 to 1 y to 1 e to the power x square dx dy. Now we note that this inner integral is from the lower limit is y and the upper limit is 1. Therefore, it should be the limit of x, and hence this should be the limit of y, because here we can see that y, the lower limit is y, so it should be the lower limit of x. So the range of y is from 0 to 1 and range of x is from y to 1, which is a dependent range. Now if we plot these lines, we get this graph, and our feasible region is this one, the region which is marked by the blue lines. So from here you can see that the range of x is from 0 to 1, this is the range of x, and range of y is from 0 to y, since y depends on this line. So from the graph we have range of x is 0 to 1 and range of y is from 0 to x. Since range of y on depends on the line x equal to y, so it depends on, so the range is from 0 to x. So our integral I2 is from integral 0 to 1 integral y to 1 e to the power dx dy becomes 0 to 1 and 0 to x e to the power x square dy dx, which is nothing again but half into e to e minus 1, simple integral calculation from equation 1. So from star we have this our equal integral, which was I1 plus I2, to be half into e minus 1 plus half into e minus 1, which is e minus 1. We can write it as 2I2, that is 2 into integral 0 to 1 integral y to 1 e to the power dx dy. So we can see that these two answers matches with option A and this matches with option C. Hence A and C are both true. Now in a similar way, it can be shown that the integral 0 to 1 e to the power minimum of x square y square into dx dy can be written in this form. There are three integral parts here. The process of evaluating this integral is same by breaking the inner integral from 0 to y and y to 1. So let us evaluate this one, which we are denoting it by I3. We know that it can be seen that this integral does not have a very good closed form, so we are denoting it by I3. So our final integral is becoming I3 minus half into e minus 1. This integral always turns out to be half into e minus 1, we have seen in the previous cases, and plus 0 to 1 e to the power y square dy, which does not match with option B and D. Hence these two options are false. Hence the only correct options here are A and C. So the correct options are option A and option C. It was a tricky problem. I hope you liked the solution. Please do like, share the channel for further interesting videos. Thank you.